So first of all, thank you for accepting my proposal of presentation. It's really glad to be here, guys, with you, and it's very nice to see a very big crowd. It's very nice to see all these people here. So we will talk a little bit about how we can solve one problem with trust firmware, which is this way we try to solve a little bit of it. So the idea is that we'll follow a very simple agenda to be very easy, start slowly, and then just pointing out what I found that could be very useful if you try to customize a board that uses this kind of technology. Before we start, just a few words about me. So my name is Gerson. I've been working with Zephyr since 2019, it's pre-COVID. And then I started with Atmel at that time, doing things here, things there, and suddenly I became maintainer. Now microchip is there too, and then I still maintainer. Let's see. And then over the time, I make a few contributions on a few drivers, so I can bring up board support, fixes. And then over time, we get some experience with device tree, trust zone, which is related with this topic today, secure boot, FOTA, and so on. Okay, so what we needed to know about this TFM? TFM is a technology from ARM, okay, only existing on those guys. Usually you see this technology more on Trusted-Firmware-M, okay, which runs Linux. It's basically secure boot, this kind of technology, but we have this kind of things for microcontrollers too, okay? And basically the idea is that you have two words. One, the security one, and another one, which is we call non-security. And then there is this big wall between these two words, and that thing is basically the trust zone. So that is the separation between these two guys. And because of that, and on the next slide I will show to you another reason, we needed to configure two different boards. One which will be the security one, and another one which will be the non-security. Here, this is basically the microcontroller of the topic. There is very small quantity of microcontrollers that has this technology. I think it's about 5 to 6 vendors, no more than that. And the micros are you don't find too much on the field. Okay. And this is the guy that we are talking about. On this slide, continue about the trust firmware, you will see the two words, security one and the non-security. And here is more clear why we needed to have two boards. If you look, you see that they are more or less twins. What that means? It means that the secure can see the flash. The non-secure can see the flash, but the address space is not the same. Okay? To understand that the security will boot in one address, the non-security boots in another address, but the flash is the same. Okay? This is one important thing. The other thing that is really interesting is that between these two guys, remember we have the trust zone. And that guys basically separate these two words in a way that the non-secure is not allowed to try to read or write from the security word. Okay? But there is a but. The non-security can do one thing. It can go in the security side and execute code. It can execute code from the security side. And that is the reason called here callable. Okay? So this is important to you to understand a little bit about the concept. We don't go more deep on this. This is the most deep that I will go here. The idea is that you need to understand that this is why we have two boards. Okay. But if we have two boards and we have two distinct projects, it means that first, I want to have my security board, of course, right? For independent of the reasons. And then what we will do, we'll put it on the open source, so everybody knows what is there, to be easy to tamper in the board. No, nobody will do that. This is why when you look on the Trust-Firmware project, the only thing that you see there is development kits and boards that runs on FPGAs, for instance. If you think about, okay, this means that I need to have a board there, I need to have a board on Zephyr. These two boards should be equal but not, because the others are different. Okay. And then how we can customize the board from the security side if you cannot put there for security reasons? There are many things that you can do, right? One of those is you can basically fork a GitHub project from the security side, from Zephyr, create a branch, put your board there, and then each time that there are a movement on the security side, you need to rebase, and this is quite annoying. And then you need to sync with Zephyr using the WAST file, which is annoying, and this is problematic, right? I saw people doing other things like, I will not create this branch, I will just pick my board, put inside Zephyr and apply patches all the time that I build that. You can imagine that is the problematic part to try to have an out of tree board from the trust firmware. Okay, then how we can try to solve this? Here my proposal is quite simple. It go more or less on this direction that, okay, let's copy that file, but let's put that file in a place that it's easy to us to handle the technology. And then here basically you have the Zephyr board, right? And inside of the Zephyr board you create a new folder, which is the name TFM, which is equivalent of the board from the TFM side. And when you do this, you can put here all your private keys, you can put here some data related to provisioning device because of root of trust for IoT devices that require that, and so on and so on. And the beauty of thing is you don't care about what's going on exactly on the upstream side. Of course you care, but the burden that you need to carry is far less. Well, then let's go to the practice about this. How we can start doing. This microcontroller that you saw is different from that one, but we can have a start point because they are from the same family. Then you can simply, okay, let's copy that content, put inside of the TFM folder that I proposed, right? For now, it's easy to understand. Then more or less we have this project file structure. So if you see, there are some projects on Zephyr that you have this NS suffix board, which is non-security side of the TFM. This is normal job. You needed to do this anyway for Zephyr, but now you have the second part here too, the TFM board here. And these allow you to, when you change one thing in one board, you change exactly the other counter side on that too. Why? Because the same amount of memory that you tell for the trust firmware, look, the non-secured firmware will use, I don't know, 500K of RAM from this position to that position. The trust firmware need to know that. And you need to define this here for Zephyr. It means that when you do the change here, you do the change for everyone. And this gives you more credibility about the change that you are doing, because everything that you do is atomic and you change at the same time the two sides. And how the magic happens inside Zephyr? It's not too complicated, okay? The majority of the part is with that kconfig, that config, that basically you need to tell on that variable, hey, look, that is the place where is my TFM board. Usually in Zephyr, that there is a pointer directly that go inside the TFM side. But now we want to change that and put in the direction that we want. In this example, I am using Zephyr base. You can read Zephyr base as your module.
your layer. And when you do that, you have full control about what's going on here, because nobody needs to know about that. So that is the most important part of the trick. The second one is here inside of the ns-config. Of course, it's your security board. You want to have your private keys for signing the image, or maybe encrypt the image, and you need to define in some place. So this is the place that you define that information. Then you need to go on the device tree, the hardware part of configuration. There is a crucial detail here that because you are using Trusted-Firmware, you cannot use anymore the hardware accelerators and your non-security side. You should use always from the Trusted-Firmware, because the Trusted-Firmware now became responsible for the crypto, responsible for the random, responsible for the everything. The certificates will be stored there in a secure partition. So nothing of that will be visible on the non-security firmware. This is how the magic happens. And then you need to use, for instance, for the entropy, the PSA random, which abstract using the IPCs, the inter-process communication things. And using these IPCs is always the way that the non-security will talk with the security side. And then, of course, this is one example, you need to define your memory. What are the regions? What is the size? It should match with what you define inside of the TFM. Then we go to the part of the TFM itself. Here, if you see the CMake, we are doing changes inside of that board that we copied, right? And then now one of the macros that we are defining here point to where we define the board. But we still need to use the STM common pointing to the TFM part, okay? So everything that is TFM hardware related will be compiled there, will not change there. But the board side will be full here, okay? Then there is another trick about the keys. Inside of the config CMake, you still need to tell to the infrastructure of the TFM, hey, please pick these private keys from this position. And this is basically what to be made on the def config side. And that's it. This is everything that you need to do to make an out-of-tree board using TFM. Such a complex thing that it's that technology to be customized today. It's very simple. Of course, there are more details, but there is a pull request that show exactly how you do this with this board. Is a proposal, and all the details are there. It's easy to anyone go there, looking on this information, understand this part, which is the most tricky part, and then the remaining part is basically what we do with Zephyr on a daily basis. It's not a big deal. But then recapping what we talk here. So TFM, it's a technology that has two words, security side, non-security side. You have a boundary between these two words, which is this trust zone. To communicate between these two guys is always using IPCs, okay? And then the challenge that could be you maintain this board around on your repos, on your project, could be very high, easy to handle if you use an approach like this one. This way, for instance, it's easy to switch everything that you need. It's easy to follow the technology by the changes, because mostly of the time what changes inside TFM are things related to hardware and not exactly with your board. So the amount of changes that possibly you needed to do are very small. But still, over the experience, from one release to another, we always broken something. I give you an example here from what happened, I don't know, 2 weeks ago. There is an update from ST.
they fix a big problem there on TFM. Yeah, and then when I was trying to test, suddenly we see a panic when I try to flip the image on MCU boot. So as you can see, it's not easy to make all these things working if you're not have a very good infrastructure behind you. And if you don't use techniques like this one, it's even more complicated. So thank you for your time. Thank you for your patience. I hope this could give you some tips about how you can handle this technology. I hope it was not too deep. And if you have any questions, I'm here to answer. Thank you.